In this video, I will be going over lesson 13, which is about events with equal chances. All right, our first question here says that Luis spins a spinner 60 times, and his results are shown in the following table. What is the experimental probability of the spinner landing on a 3? Okay, so if I look at my table here, it says that he landed on a 3 15 times. And I know he spun his spinner a total of 60. So if I were to take all of these here and add them together, I would get 60. So 60 is my total, which goes on the bottom. And then the last thing to do is to simplify. So if you don't want to simplify this on your own, or if you struggle, remember you can always type this into Desmos. So I have 15 over 60. If I hit this button here, it will help me simplify it, which will get me 1 over 4. So 1 over 4 is the probability of him spinning a 3. Our next question says that a bag contains 2 blue, 2 red, and 2 yellow marbles. If Jenna randomly pulls a marble from the bag, what is the probability that she will pull a yellow marble? Enter your answer as a fraction. Okay, so she has 2 blue, 2 red, 2 yellow. 2 plus 2 plus 2 means she has 6 total marbles. 2 out of those marbles are yellow. I can simplify this to give me 1 over 3, which means that she has a 1 out of 3 chance of picking a yellow marble. Our next question says that a bag of 25 marbles has yellow, blue, red, purple, and green marbles. The probability of drawing any of the colors above is 0.2. Which bag of marbles best models this situation? So for this problem, it's actually a little bit easier than you might think it is. Since each of these colors have the same probability of 0.2, to figure out how many marbles of each color are in this bag, all I need to do is take this 25 and multiply it by 0.2. And you can just very easily type that into Desmos. 25 times 0.2 gives me 5. And if we think about it, if I take 0.2 and I convert it to a fraction, right, I get 1/5. And you could also do 1/5 and multiply it by 25, and you will get the same 5 here. So for this one, there's 5 of each of these colors. Each one has a 1 out of 5 chance of being drawn. Our next question, so here we have Jenna's same bag of marbles, but now she is drawing a marble and record the color and then puts it back, and she does this 15 times. So how many of those times should she expect to pull a yellow marble? So this is where we're getting a little bit different with, or a little bit more into it with our probability. So we need to take what we know about the probability and then apply some extra math to it, okay? But it's not that bad, I promise. So if we think back to this problem that we just did, the probability of pulling a yellow marble was this 1 over 3, right? We already solved that. So she has a 1 out of 3 chance of pulling a yellow marble. If she wants to know, well, how many times can I expect it if I do this experiment? A total of 15 times. Remember, your total goes on the bottom, okay? So if I need to go from this 3 to 15, I need to multiply by some number. 3 times what number is going to give me 15? Think about it. 3 times 5, right? 3 times 5 gives me 15. So I'm going to do the same up top. 1 times 5 is 5, which means that she can expect to pull a yellow marble 5 times. We'll do more examples like this, don't worry, so you'll see it again. Our next question, Gene needs to create a probability model for a bag of 24 marbles. He randomly pulls the marble from the bag, records its color, puts it back, and then repeats. The results are shown in the following table. He determines that the bag of marbles must have 12 blue, 14 red, 13 yellow, and 14 green marbles. Is his probability model correct? Why or why not? So if you reread the first sentence says that the bag has to have 24 marbles, right? So if the bag has only 24, how can it have 12 blue, 14 red, 13 yellow, 14 green? That's way more than 24, right? So no, Jean's bag is supposed to have 24 marbles, like it says in that first sentence, but it actually has 53, which is what you get when you add all 4 of those together. So his method was almost there, but a little bit of tweaking was needed. Our next question says that Reese rolled a 6-sided dice 100 times, and the results are shown in the following table. If Reese were to roll the die 25 more times, approximately how many of those times should he expect to land on a 1? Okay, so here I have 16 times I rolled a 1. So first let's start with the probability. I have a 16 times out of the 100 that I rolled, right? It says up here that he rolled this dice 100 times, right? So I have 16 over 100 because that's how many times he actually rolled that 1. Now let's simplify this, okay? Always simplify these. It makes solving them much, much easier. So 16 over 100, I can simplify it to 4 over 25. Whoops. 4 over 25, okay? Now the question here says that if he were to roll the dice 25 more times, how many times could he expect it to land on a 1? Well, remember your total always goes on the bottom, which is 25. And if I look at this fraction right here, 25 is already in the bottom, which means that 4 out of those 25 times, he could expect it to land on a 1. So this question was a little bit easier than that first one that we did, which is okay. Alrighty, next question says Tracy flips a coin 36 times. How many times should she expect it to land on heads? Okay, well, when you're flipping a coin, it can either land on heads or tails, right? Those are the only 2 options that you have. She is flipping a coin 36 times. So out of those 36 times, I would expect half of those where she lands on heads, right? Because you have a 50-50 chance of landing on heads or tails. So all I need to do is figure out, well, what is half of 36? If I take 36 and divide it by 2, I get 18. So she could expect it to land on heads 18 times. And that is it for lesson 13. If you have any questions, please let me know. Other than that, have a great rest of your day.